Thanks.
All right, my name is Alexander Miller. I will go a bit more into my bio in a second. I wanted to say thanks for the opportunity to speak to you guys today. I was supposed to talk a month ago, actually. I have a toddler in daycare, if you guys know about that life. And she brought home something especially virulent for me, and I was not in good shape a month ago. I'm going to try to talk for about an hour. I think that's the expectation. Someone please yell at me if it's not. I have put the slide deck I'm going to speak on top of both in the Zoom chat and on the meetup page. It's kind of long for an hour. I'm not going to belabor every slide. It's a pretty good deck to just read, especially if you were here and you saw the talk. It's got some links in it to other resources. So if that appeals to you, feel free to go and grab it. There is a widget you can play with via a binder of Jupyter notebooks if you want to cut to slide 16 and just play with that and not pay attention to anything I've said. That's an option. When I get to slide 16, I'll tell you about what it is. What was my last thing I was going to say? Oh, I would love it if this were conversational. There's plenty of content. If you guys just sit and listen passively the whole time, I will assume that you hate it and I'll feel really bad. So you should ask some questions just, like, because I'm guilting you now. So just think about that, even if you don't enjoy the talk enough to, or you're not paying attention, just pretend for my sake. Okay, so hold on. What's the point of this presentation? I'm going to talk about some interesting, weird regulatory stuff that's been going on with data. And I'm going to do it in part because it motivates a particular technology that I'm really interested in. And I think it's going to become really important over the next few years. In particular, I'm talking about technologies, particularly like homomorphic encryption and federated learning, that are about keeping data obscured while still doing useful work for it. And so in the beginning, some of this transatlantic data stuff I'm going to talk about, it's admittedly not the kind of most pressing, hottest application of this tech, but I think it's a pretty clean story of what the tech is good for. And also it's just a really weird story that's not very well known. And I think it's interesting, and I hope you find it interesting as well. So just kind of go over this agenda real quick. I'm going to talk about all this stuff that's been going on with the European Union and GDPR. They're kind of endlessly fighting with Facebook in particular. It's a pretty weird situation. And then the second half or so of the talk, I'm going to talk about some technological fixes to this problem and give some perspective on them. Okay, so who am I? I was originally a math guy. I did a doctoral degree. Like a lot of people kind of on that track, I wanted to escape from the ivory tower, and I worked in data science for a few years. I got kind of enraptured of this emerging technology. It was both something that sort of suited my educational background. I thought, frankly, was really cool. And then also, I don't know if anybody here works with sensitive data, but you waste a lot of time. Can I get the data? Oh, you forgot this column. Can you get that to me? Fighting with bureaucrats, compliance people. And I think the kind of stuff I'm going to talk about in this talk, I was originally attracted to it because I thought it could be transformational for these kind of problems. Does anybody in the room work in, healthcare or PCI compliance or any of that kind of data?
I think a few of the Finicity people probably do, right? Yeah, Dan here in the office does.
Yeah, so I used to work for a large health insurance company. We were bound by HIPAA. My general sense of HIPAA, I'm not a compliance guy, is, it's just really in the end, everybody's too paranoid to give you the data to do anything, or that's kind of how it felt to me. Once again, this is the link to the slides, and then you can, once you have the PDF, you can get my email, your LinkedIn, and my GitHub if you would like any of that information. Okay, so I made this deck a month ago. I think, I made some updates. It's been a really interesting month for this topic I'm going to discuss. So I'm going to kind of start at the end. There's a link to an article here. Some of the issues I'm going to talk about have been coming to a head. Maybe you will see them in the news again. They're kind of on the cusp of people in Europe banning all of Meta's data transfers to the United States, which would be really big. I'll talk a little bit about maybe this is not actually going to happen, but it's an interesting story. So I'm going to kind of go back. You can read this article. I'm going to rewind in time and kind of tell like how we got here. So Facebook's all over the world, right? They end up with a lot of data on European nationals. Europe, if you've heard, generally is more privacy conscious than the United States. This is embodied in the GDPR, among other things. It's kind of a big deal to be transferring all this data about all these people in Europe embodied in their Facebook data to the United States. And there's a really long and turbulent, weird history of essentially politicians and diplomats fighting about this. And specifically, we've gone through these cycles of diplomats will sit down and they'll make some kind of agreement about when people are allowed to move data from Europe to the United States. And it keeps happening over and over that then later courts in Europe decide these things are illegal. And now it's kind of getting to the point of like, maybe this is just illegal and nobody knows what to do about it. And kind of that article I just showed is that issue coming to a head. So this is going on all the time. It's been going on in just the past few months. So we had previously had 2 of these sort of agreements about what you could do with data, and they're kind of working on another one now. And I think one thing to notice here, if you're interested in this kind of stuff, is it's really a headache if you're an engineer, because a lot of this stuff really lives in the diplomatic and political realm. So there's not stability of knowing you can build something and you're done. The reality is it's kind of this thing that everybody's always fighting about, and stuff keeps getting shut down and blown up. It gets mixed together with a lot of other diplomatic issues, what the next data transfer issue is going to be like. That's a headache if you're trying to build something and you might have customers potentially in Europe, or really do anything with data coming from people in Europe. So why does anybody recognize this guy? Yes, no?
Yeah.
So the issue is that Europe kind of looks at the United States and thinks that the United States government is going to spy on any data that's sent over here in a way that's illegal in Europe. And that's kind of the background, especially on this like saga of all these things endlessly getting shot down. So another name that you could take away from this is Max Schrems. Has anybody heard that name before? It's a little more obscure. So this fellow is a privacy campaigner in Europe. And he basically just sues Facebook over and over again every time they have one of these new frameworks. And he's been winning. So they've had 2 of these. They're now working on the 3rd one. It just keeps happening that whatever agreement that the US and the European Union come to about what is Facebook supposed to do, it turns out to be illegal. So I think it's really fascinating, kind of a wild situation that a really large company like Facebook, love them or hate them, really actually operates in this really important market, more or less in legal limbo for big stretches of time. And a lot of people, knowledgeable people, kind of regard them, maybe they've always been illegal. It's kind of a crazy situation. Okay, so it's really easy to run into trouble if you're doing anything with data about European nationals, building an app, or for any kind of reason. If you're, like you've got a web store, if you're getting people's names, email addresses, if you've got a website that's doing cookies, just about anything where you get information about an individual person, which is a big chunk of anything that's worth doing, you run into these regulatory issues. So for a big class of possible applications, you're not going to escape with these stuff. Okay, so I'll stop there a second. That's kind of one segment. The big high-level idea is that it's actually a really weird situation. It's really hard to take data from Europe to the United States in a way that you can have confidence will be legal and stay legal. Does anybody have any questions?
I mean, is the push with what you just mentioned, stay legal and everything else, is the push to just say keep the data in the EU? In other words, if you're US based, is the goal really just leave it over there on a cloud in the EU and not bring it back this way at all? Is that the
I think that's kind of a nuclear option that everybody is aware of. So it is not at that point yet. Once again, it would be kind of sensitive and it would turn into diplomatic trade negotiations, because if you're an American cloud provider, this is essentially taking that market and handing it to a European competitor, which, those big, Microsoft and Google and Amazon are going to lobby the federal government. And then the federal government is going to talk to Europe, try pretty hard to keep that from happening. That's a great question, though, because, other than this magic trick I'm going to describe in the latter part of this presentation, it's not really clear what people are supposed to do. It's not really clear what people are supposed to do. And that is one thing you could do. You could just host Facebook entirely internal, put it in Ireland or somewhere. That would solve the problem.
Yeah. So also, Shelley on the chat mentioned hope for a new framework. What kind of framework? Open source, maybe, as an option.
Yeah, so these frameworks are these kinds of, they're basically international treaties that say you can do this in like a certain type of situation. And maybe that's a great segue to this slide. So they're going to list, they're very open. They're trying to tell you what to do to stay out of trouble. And the problem is they keep just turning out not to be all the way legal in the judgment of European courts. So avoid data in the clear. That's really what the whole second part of the presentation is about. There are things called standard contractual clauses, which is you have some agreement, very specific agreement about the data is going over here to do exactly this, and this is given in writing. And this works for smaller companies doing circumspect things. Facebook has a crazy data fire hose, which is why they're the one that's always in trouble, because they're not going to be able to do these kind of standard contractual clauses. And then also, the standard contractual clauses are part of what keeps getting changed around in these frameworks. So they'll say you're allowed to do it with this justification, and then it kind of turns out later, okay, you have to change it. And that can be a really big headache if you've built business and or software around that particular justification.
Okay, there was another question in chat. So is it illegal to collect the information or just illegal to send it to the US?
It's illegal to send it to the US. And once again, the point is that if it's on a server in the US, that the NSA's surveillance apparatus, a la Edward Snowden, can sniff at it. And Europeans feel like they have to some degree to presume that's going to happen. And that is very illegal relative to European law.
Okay. And another one in the chat from Shelley. What if every individual controlled their data locally and then chose to share it where they want? Would that alter the perspective?
Yeah, well, if you control your data locally, and I'm going to talk, the second part of the presentation is sort of magic tricks that kind of help you keep data local under the term federated learning, which is kind of like the AI version of what I'm going to talk about. I'm not sure to what extent you get out of trouble if you're volunteering it, but I think it's probably still a problem if you give it to somebody and it ends up in the United States.
Right. Okay.
Yeah, well, I'm going to talk about how to keep the NSA from sniffing things, by the way, to the extent that that's possible. Yeah, also, this is kind of a gag, but it's this endlessly weird political exercise. And if you haven't been following this for kind of arcane reasons, it all ends up, Facebook is headquartered in Ireland. So Ireland is a relatively small country in Europe, has really outsized influence on data privacy issues. And Ireland is kind of always caught in between like the US and the France and Germany. The US wants, Facebook to be able to do whatever it wants, and France and Germany want Facebook to be able to do nothing. And it gets pretty weird. Okay. So the segue to the new technology is that the European Union puts out regulations periodically about what you might be doing to comply with these things. previously, some of the recommendations were pretty restrictive. There's this new technology you might call encrypted data in use. And I'm going to talk a lot more about what this means. But encrypted data in use is that, like you have encrypted data at rest, encrypted data in transit. The idea is you can keep it encrypted and actually use it. And that is very empowering relative to these rules they put out. So pretty plain, you can take personal data about Europeans and encrypt it and keep the keys in Ireland and send that encrypted data to the United States. That's okay. That's okay. And then the problem here is, of course, well, can you do anything that you needed to do with it if it's encrypted? And exactly the kind of technology I'm going to talk about is, well, how can you do useful things with data that stays encrypted in order to comply with these rules, this guidance from the European Union Data Protection Board? So you're obeying the rules, and then you can do what you want to do. And so the headline of the talk is, this is actually very empowering if you're sick of this weird eternal dance between government of the US and organizations, pan-European organizations in Europe, because this is likely to stay kosher stably for a long time. Doing these standard contractual clauses or just trying to be really scary to the Irish government is maybe not going to give you that kind of stability. And so they say a few things explicitly you can't do. I already mentioned the cloud. You might stand up an application in the cloud and want to serve an app to people in Europe, but then the data ends up on servers in the United States under the control of US companies, and that's not okay. And in the old way of doing things, before these new magic tricks I'm going to talk about, this was a big headache. It erected a lot of hurdles to doing things in a legally legit way if you're trying to have European customers. Okay, so there's all kinds of different technologies to keep data from being in the clear. So I can't claim that the European Union is telling people to use exactly what I'm talking about. And so maybe some of you have seen, especially maybe the healthcare crowd, you can tokenize things, you can mask, you can do all kinds of things to disrupt what's underneath the data. Encryption is just one example, and I'm going to be talking the rest of the talk basically entirely about fancy new space age modes of encryption that obscure the data, but then you can do these extra tricks with it. Okay, so real quick, common terms you hear. The kind of stuff I'm going to talk about, it's easy to misunderstand a little bit. So encrypted data in rest, that's you just encrypted it and you put it on a hard drive. Encrypted data in motion is you encrypt it before you send it over whatever data transmission mechanism you might be using. And so a lot of these, now if you're especially working with the public cloud, these will be totally baked in and you won't even see them, but they're there. Encrypted data in use is this idea. There's a bunch of different names attached to it, and they're all really, if you find these names intimidating, that's totally fair. Homomorphic encryption, zero knowledge proof, federated learning. I'll talk a little bit more about what these means, but the idea is always that data is encrypted, you don't decrypt it, and you have a special magic trick that lets you do something useful with it, like join two tables together. You could have two tables of encrypted data. You wouldn't know anything that was in them. You could say, I want to join these together. And then you would get the joined table back and it would still be all encrypted. And the computer didn't actually decrypt anywhere. So that's a pretty powerful tool if you're doing kind of basic data engineering work. You're trying to get a table together. You're trying to munge. And you can do it while obeying all these rules because you didn't actually have to see the data. How a join works is actually an internal relationship that doesn't require actually exposing what's in the data. So I'll stop there a second. I bet that I had a lot of education to prepare me for this kind of idea. When I first heard it, I thought it was pretty weird and counterintuitive. So if it feels uncomfortable like a magic trick, that's okay. I think it's pretty reasonable to feel like that.
I just haven't heard of that idea or concept because basically you have to unencrypt it to do something like a join, which has a cost expense to it to unencrypt and then re-encrypt essentially.
Yeah, and so you are exactly not unencrypting. That's the magic trick.
Yeah. That's a little interesting. Let's hear how you do this. Fitz mentioned, are things like surrogate keys also encrypted?
I can't give some kind of, there's all different kinds of key hosting paradigms and different versions of this text. I don't think there's a good answer to that question. Like if you want to encrypt them, you definitely can. And of course, these kinds of encryption techniques, they have their own special keys. You can't encrypt using an algorithm you're using before, like AES or RSA, and then do this magic trick. You have to encrypt in a special way. But then in this kind of new world of these new encryption techniques, all kinds of stuff is going on. Okay, so for skeptics, I'm going to try to wholesomely avoid selling my own widget. My company makes a software development kit. We open sourced it only last week. If you want to go to Binder right now and play with it, you can. You should follow this link. There's a few demo notebooks in there. Our particular widget is designed to be really easy to use to the extent that that's possible for kind of space age counterintuitive technology like this. So I encourage you to open that up. I've also never sent people to this Binder thing en masse before, so if it crashes and burns, I'm sorry. You guys are a little bit guinea pigs right now. And that's going to be up there if you want to play with it later too. So also please be mindful, potentially lossy. No, not potentially lossy. Not potentially lossy. Collisions is a kind of specialized thing, right? So to explain for the rest of the room, if you had like a cryptographic hash function, the cryptographic hash function is you take an input and it maps that into a very unpredictable long string of highly random gobbledygook. And if you put the same two inputs in, you're not supposed to get the same input out. This is subtle, and I don't want to get too into it because there's infinite technicality we could talk about all night. A lot of these homomorphic encryption schemes are malleable. It's a cryptography term. There might be randomness involved in the encryption. So it's even true you could encrypt something twice and get two different ciphertexts and do that all day. So there are not collisions, but it's a really long, weird story about non-collisions, if you'll accept that answer. So yeah, no collisions. I'm not going to talk any more than that because we could go on forever. Okay, so just to kind of like go deeper on the big idea of encrypted data in use. You have two encrypted somethings or other. And this goes back to the join example. A join at some point is about, is this, you're joining on these two columns. Is whatever is over here the same thing as whatever is over there? Joining is built on a lot of yes or no answers to this kind of question. And so you could ask a question like, okay, does this piece of ciphertext, AS5, etc., if I could decrypt it, would I get the same thing as if I decrypted this other piece of ciphertext, P44HD, etc., and so on? And so the way this stuff typically works is I'm not going to decrypt. I have encrypted in a special way so that I can do some weird follow-on math. And if the answer to my question is yes, that follow-on math will magically work out in a very particular way. So I knew that they were the same string, whatever it was. I don't know. I don't learn what the string was, but I learned because of this weird miracle in my follow-on computation, yeah, it's the same. And then I can join together on that cell. And then likewise, if that miracle doesn't occur, I know that they weren't the same string. And so this extends to all kinds of other computations as well, actually. If you're willing to do the work in kind of setting these algorithms up, you can do a lot of different kinds of computations without actually seeing the underlying data. Okay, so here's kind of a tease. Does someone in the audience feel confident they can do some just basic bookkeeping arithmetic for me? Do I have a sacrificial victim?
It's got to be somebody online because I'm going to say no.
Okay, all right. I'll go easy on you guys. This is a new format, so. But if we were all in the room together, I would stare at you until somebody was the guinea pig.
Oh, wait, we had one taker here in the room, so I'm going to pass the mic. Oh, hold on. Walking over. There you go. Okay, what do you got?
Yeah, so if you look at my slide, I just want you to do like a really simple audit of these numbers. I can't, they're too sensitive, the actual numbers. I don't want to share the actual numbers. Could you just kind of add everything up and make sure that the starting funds minus all my spending is the ending funds? Could you do that for me?
No.
No? Okay, why not? Because I've obscured the data, right? I didn't actually want to show you.
Right.
So the point here is that you can use this kind of technology to do exactly this. And I'm going to explain two of these kind of big, awful words that go into exactly completing this task. So completing this task, you could call it, you're using homomorphic encryption, and then you're using zero knowledge proof, and I'm going to say what those are. Okay, so first, homomorphic encryption just means I can do arithmetic operations on ciphertext, and I get new ciphertext. That's the right answer. So in this diagram, like let's say I had 5 and 7, but they're secret. But I'm lazy and I want you to add them together. So I could encrypt them and I get some like 4JG and MQZZ stuff. I send that to you. And we could even already imagine here that I'm in Europe and these are European secrets and you're in America and I don't want my information to fall into the hands of the NSA or whatever. You've got a special algorithm. And your special algorithm, you're going to put those things I sent into that algorithm. Into this algorithm you call addition, and you're going to get new ciphertext, new impenetrable gobbledygook. In this case, 60KQR1. And the magic trick is that you know that whatever the numbers you gave me, that new thing, that 60K, if you were to decrypt it, it's the right answer for the sum of the two numbers. So you can do essentially arithmetic computational work for me blind. You don't actually have to see any of the numbers. So this idea is called homomorphic encryption. Another one, and is anybody interested in the crypto space at all in here? No? Well, now is not a time to, okay, I was gonna rip on it, I'm sorry. Crypto winter is where we are right now. The zero knowledge proof idea, before I say what it is, it's gotten its most traction in the cryptocurrency world. It's often employed in what are called privacy coins at times. The big examples are Zcash, Monero, and then there's something called Mimblewimble that Litecoin implemented. And then there's also a Mimblewimble coin. But the point of all of these is they have a higher level of privacy because you don't have to put as much information on the blockchain. So I don't know if you've heard of that before. You could look out for it. They have some pretty cool stuff implemented. Like in Zcash in particular, they're just really awesome mathematics. I love it. Not necessarily investment advice. I don't know. I have a whole other presentation about privacy coins, but anyway, this is out there. Okay, zero knowledge proof is this idea. I want to prove something to you and about information I hold, and I don't actually want to show it to you. So a really super common example that's used in your browser every single day is a digital signature. A digital signature is the situation I have a public and a private key. The private key, of course, like I keep that to myself, that's a secret. Public key I give to everyone so they can encrypt messages and send them to me. A digital signature is exactly, I do a bunch of weird mathematics that proves to you that I have the private key that goes with a public one, but I didn't actually have to give you the private key. And so this is really important for establishing identity. It's used all over the place under the hood, probably like 100 or more times today. Your computer did this for you. Website certificates, all this stuff, it's in there. Okay, it's actually kind of easy to explain how all these things work. So this is like the stock example. I stole this picture from Wikipedia. Peggy starts with a P, is trying to prove something to Victor, who's going to verify that it's true. So the setting for this is there's a donut-shaped cave. There's a magic door in the back. Peggy claims she's got a way of opening the magic door, but she doesn't want to show Victor how her trick to open it works. So does anybody have a guess how she could show Victor that she has the key?
Does it count as a guess if you're already familiar with the example?
Well, in a dictionary definition, no. Yeah, I mean, well, let's keep going. Give somebody else a chance, and then we can jam on the next slide. She sends V down B while she goes down A. That's pretty close. Okay, well, let me just keep going. So Peggy could just go in the cave, and she could have Victor shout out which path she should come back by, A or B, right or left. And so the point here is that she's only going to be able to perform this magic trick, doing what Victor asked consistently, if she has the key. So if she didn't have the key, half the time she would only be able to come back whichever way she went in, right? If she does have the key, and notably this is slightly probabilistic, you have to run this trial a few times, she can always do what Victor wants, and then how could she be doing that if she didn't have a way to open that door? Okay, so the point here is that if I have these two magic tricks, I can use my homomorphic encryption to subtract all of these spending amounts from my starting funds. And then I could do a zero knowledge proof of, well, I don't necessarily want to find out what that number is that I computed if it's not 30,173. I'm going to do a zero knowledge proof. Is this ciphertext number I got from homomorphic encryption equal to 30,173? And so, yeah, you can audit data, do some bookkeeping and perform an audit on some data. You don't need to see the data. Okay, so this is maybe the second good stopping point of the talk. Does anybody have any questions right here? By the way, did anybody go and play around with the binder? Sounds like no. Okay. All right, so now I'm just going to talk more tangibly about different libraries for doing this, about our library for doing it, about different kinds of use cases that maybe overlap quite a bit. So first, this area has a lot of like really big, strange names for things. Actually, they all overlap a lot. So to some degree, when you see one name and not the other, it's about what is the goal? What is the setup we're doing, trying to use this tech for? So federated learning is kind of the AI version of this. It's the idea, it goes under this tagline, well, you send code to data, not data to code. A good example is maybe hospitals. You know, like what if I was going to model sepsis? Who's going to get sepsis? That's a pretty popular one. I want to build a model of who's going to get sepsis. I want to combine a lot of data from different hospitals. Federated learning is this kind of magic trick of, well, I'm somewhere not at the hospital. I'm going to do a kind of weird handshake with systems at all the different hospitals. They're not actually going to send me their data. They're going to send me different specially encrypted or obfuscated data. And I can actually leverage that special obfuscated data to build my model. And this extends from linear regression to very sophisticated deep neural nets, whatever you want. I can build my model without actually seeing the underlying data. And this is like a really great magic trick. And the hospital example is a pretty good one. Hospitals don't want to give some random data scientist all of their data. They don't want it mingled with all the data from the other hospitals. So this makes it a lot easier, among other things, to just let people give you enough access to do this. And then also there's less risk for them, cybersecurity risk, data privacy risk. Homomorphic encryption, as I just showed you, is more like this transatlantic data transfer scenario. Data gets encrypted in Europe. It goes to the United States encrypted. The application server handles it encrypted via this homomorphic encryption technique. It goes back to Europe. There's never any plain text in the United States, so you obey those European Union rules. And then you can actually build whatever you're building and not have to pay lots of lawyers to be mean to the government of Ireland all day. Okay, I'm going to go into more detail. So if you open the binder, we have a software tool that does exactly this. We tried to make it really easy to use if you already know how to do Python. You can do things like encrypt a string and slice the string and say, are the first 3 letters of this cell in this table, are they the same or not the same as the first 3 cells in this other, the first 3 letters in this other cell. I got a question. For the hospital example, would a given patient that went to multiple hospitals have their data encrypted differently for each hospital? Per your earlier, same data can be encrypted differently idea. So it's worth noting there's a couple senses you can say of encrypted differently. So if you wanted to do this federated learning idea with the hospitals, the data has to be prepared and encrypted in a special way. You can't just take it off the shelf, RSA encrypted, AES encrypted, whatever you were doing before. Some of these older algorithms, you can't just take it off the shelf and do this trick. You've got to encrypt it in a special way. My earlier remark, what I was intending was, and maybe this is a great slide to be on, it's possible for most of these homomorphic encryption algorithms, and it kind of has to be this way. It's possible that all of these were the same word in this column. So going back to this non-collision thing, these will still decrypt correctly. It's just if I encrypt a word 5 times, I not only am not surprised, I expect that I get different ciphertext each time. And this still works for the homomorphic part. It still works for when you decrypt. But what the ciphertext is, there can be many ciphertexts for any given thing you tried to encrypt. And everything works totally fine, even with that being true. Okay, so this is about our widget. We have a pretty unique wrinkle of this other idea that looks like this other concept called functional encryption. I won't go into it, but our tool is designed for if you're doing everyday stuff in Python, stuff you might be familiar with from pandas or the like. We have a very similar interface, similar data objects. You can do a lot of the same stuff in the same way. Joining tables is a great example, but then you don't actually have to see the data. And you can go play with it in Binder if you want. Okay, so I want to talk a little bit about these 2 different ideas. First, this federated learning idea. This is the analytics and modeling corner of, by the way, before I forget, there's a whole lot of this stuff going on right now. It's getting more attention. It's under the term privacy enhancing technologies, which is pretty bland. But there's things like federated learning, homomorphic encryption I'm going to talk about. Has anybody heard of differential privacy or synthetic data? Crickets. Okay, so these are, go ahead.
None
You gonna
here.
say something, Pat?
Nope, just none here.
Okay, so there's more of this stuff out there, and some of it is kind of similar looking. I don't have time to talk about all of it today, but just be mindful if this stuff is interesting to you, there's a whole lot more of it. Okay, so federated learning is this idea we're sending code to data, not data to code. There's going to be a modeler somewhere that's distinct from where the data is held. There's going to be somebody monitoring. Data is prepared in a very special way before it leaves the data holder, which in my example was a hospital. The modeler is going to get like a very special digest of what's in that data. And the point is that they're not supposed to be able to retcon it, work it backwards to get the original data. I have a funny metaphor. Does anybody, Hungarian cuisine, if anybody's into that, has a lot of paprika in it. And let's say I'm opening a restaurant. My menu is kind of like a model of consumer taste. And I don't want to tell everybody how I made all of my food. Federated learning algorithms often kind of work like, well, if you just tell me if you thought I had too much or too little paprika, that doesn't really give away my recipe. And that helps me make my menu, my recipes, better, which is kind of like building a model of the consumer taste. And so the idea is that, I'm getting this kind of very fine course correction that doesn't actually say that much about what was in the food. But actually, if I get a lot of it, it's actually pretty useful, and I can end up making a very good dish for you. So that tends to be how federated learning works. Once again, I'm sending code to you to tell you how to make this mathematical digest to help me build my model and protect your privacy. And then the point is that you don't have to send data, which you probably didn't want to do because of HIPAA, or because you don't trust me, or because, it's funny, actually, I'm an entrepreneur. What I hear about a lot is, well, they don't have enough money for us to sue them if they screw up. That's like a real thing people bring up a lot, which is funny. Okay, I'll keep going. The other one, as I mentioned, is this homomorphic encryption idea. So you've got your users in Europe interacting with some kind of application that you would like to host in the United States. If you have set things up appropriately so that the keys stay in Europe, and this is something they said explicitly, and it's important, you shouldn't have the keys and the data both in the United States. That defeats the purpose. But if you've got the keys secure in Europe, you encrypt any data before it goes over. You can use homomorphic encryption, do whatever you're going to do on that application server. The encrypted data goes back to Europe where it's decrypted. To the end user, everything's exactly the same, actually. You wouldn't show this to someone who's using a CRM or was using a medical health records platform. Everything would be exactly the same to them. And they wouldn't even know that everything leaving their browser was getting encrypted before it went wherever it was going. So this is a pretty cool trick. I talked at the beginning about, well, the GDPR in its current interpretation, you can send encrypted data to the United States. Without this kind of technology, that's kind of useless, right? In that you send encrypted data to that application, it can't do anything with it. It can't, like you say, give me Bob's record. It can't figure out who Bob is. And this transforms that problem. So now you can actually have the thing running and doing the things that it's supposed to do, but you don't actually have to expose the data in that way that's going to get you in trouble. Okay, so here are some links. There's like a lot of this stuff out there now. It's kind of been getting bigger and bigger and bigger in the last, I want to say, 4 years. And it's maybe since 2010 that people kind of woke up that this was possible. So this is a non-exhaustive, not necessarily endorsed list of things other things you could tinker with. Some of them are fairly hard to use. Others are a little bit better. So I'm going to go down the list real quick. And these are all links, by the way, if you got the deck. So OpenMind, they, on their GitHub, have everything that's ever been done in this area, which sounds good. And it's also bad in that they're not doing any quality control. So they also have all kinds of weird half-finished stuff that doesn't really work, or nobody's maintaining it anymore. And they don't do a great job telling you which is which, but it's a great place to get started. They kind of mirror lots of things other people are doing. I think there was a little bit of a nascent business idea there to like provide resources for training. I don't know if it really got off the ground, but they're trying to start a community around this stuff. They've done some good things. They might do more good things in the future. It's worth checking them out. If you're a little more technically minded, WeBank in China made a really sprawling federated learning system called Fate AI. They've got the kitchen sink in there. They implement all these cool algorithms. They have lots of links to academic papers about what they're implementing. They have a really sprawling web presence. They've used every different kinds of messaging system and like different backend you can possibly use. So if you're just looking for kind of the kitchen sink, look at other implementations of things, looking for references about how they work. It's great. There's also the side problem that if you read the docs too long, you'll eventually get to one that's in Chinese. And then also, if you're trying to do this as work, they'll start to get paranoid that maybe the Chinese military built a backdoor into this, and I can't speak to that either way, but it is a Chinese product. Secure multi-party computation is another one. There's a tool called CipherCore, relatively easy to use in Python. It's going to force you to do work with some kind of mathematical constructs about how this actually works you might not want to work with. And then if you're going for the kind of full bore, fanciest, most modern homomorphic encryption, there's a library called Palisade. If you go to their website, I think you'll see kind of rapidly that it's maybe for advanced users, and they've got like 40 different kinds of keys, and they talk about this or that implementation. But if that's what you're looking for, that's the place to go get it. Okay, so I'll stop here, and I guess I could show if anybody went to the binder, which it sounds like nobody did. I think everybody's had this experience where Jupyter notebooks crash every 10 minutes. Oh my gosh. Okay, hold on. Is anybody interested in looking at some of the stuff on binder?
Yes.
Did I get a yes?
Yes.
This is a great question from Naresh. Are there any restrictions on encryption software to use to encrypt the data that is developed within the European boundary? This is a pretty weird, unsettled area. So I sent everybody to my GitHub. This Python library I'm showing to you, the current regulatory situation, as I understand it, is I have to tell the NSA anytime I do anything with it and make the code available to them. There's a kind of unpleasant, strange history of, does anybody know PGP? Heard of PGP?
Yes.
Pretty good privacy.
Yeah.
The guy who first made that, he really got raked through hell because the NSA at the time, it was prohibited to export any kind of cryptography. At the time, this was interpreted to extend even to open source. So he got in lots of trouble, and it was a really big mess and just really miserable situation. Since then, the laws have changed, and you can export these things if you obey all these notification requirements. But it's a kind of strange space, and it evolves a lot. So this is a great question. The answer is really no. Oh, so here's another one. So like it goes on all the time. I bet a bunch of you have used WhatsApp or Signal or Telegram, right? Yes. I would think. Yeah, absolutely. And so they have this end-to-end encryption.
Yeah.
Law enforcement hates this. So law enforcement is always trying to, like talk to legislators about, can I get some kind of way to get into the WhatsApp messages, Telegram messages, Signal messages of this person that's under investigation. And it's a really strange situation because nobody can really think of a good way to do this, but key escrow, where they steal your keys and hang on to them in case they want to spy on you, which really defeats the purpose. So the reason I tell this story in response to this question is, no, there are not restrictions right now. There are some burdensome, weird vestiges of restrictions, and they're kind of flirting with making new restrictions all the time. And I would expect it to continue to evolve. A new question. Do you effectively need some degree involving international law or an advanced degree in cryptography to stay on top of this, or maybe an attorney on retainer? This is a great question. So my personal calling, why I founded my company, why I built this thing, I'm going to show you, is my mission was to make this something that people could really actually use. And so we try really hard over here. If you know how to use Python, you can use this. and you don't have to understand all of this cryptography. Maybe just a second ago, I showed you, let me bring it up again. I showed you a few different libraries that are out there. And I would say that these different libraries, it's all over the place how much of an expert you need to be to do something. So these open mind people are trying really hard to not necessarily make things super easy, but to kind of provide training and kind of take you along the way. These Cipher Core people do a pretty good job. These Palisade people, I feel like don't. You need to know a lot about cryptography to understand. Actually, let's bring it up. Yeah, Palisade now supports the BGB, BFV, CKKS, and FHEW schemes. This is for advanced users. So the answer to your question on the cryptography side is no, not really. It's getting better and better. It's a really new tech. And so, well, here, let me find a good example in here. Yeah, so I have two encrypted frames. I merged them here. You don't need to know how they're getting merged. It's, once again, you just kind of need a high level understanding. There is a lot of math that is being handled by software for you. You don't have to see it. And this is one of the major trends in this space, is we are all trying to make this easier for you so you don't need to see the cryptography. Because once again, the whole point, like you're adding these two numbers I sent you in that example. You don't need to know how it's happening. You just want to push the button and say add. There's no reason you need to have an advanced degree. Apropos of international law, no, not at all. And so, like my actual day-to-day, I'm running around trying to promote this stuff. Very often the people that have degrees in law say no, and then you try to convince them. But to use this kind of stuff, to know why it's important, even to kind of know the role it serves relative to the law is not that exciting. So, you saw that European Data Protection Board guidance like everybody else. Let me go back up. These are actual screenshots from the actual guidance they put out. I would not say you need to be a lawyer. Just you don't need data in the clear. That's what they wrote in the rules. That being said, I've been kind of ripping on these standard contractual clauses. Those make my head hurt. I am not a lawyer. They're very specific and they're written in legalese. So exactly, how I build this presentation is using this tech as a way to not have to get into having a degree in international law. Okay, so just to go real quick, there's a few demonstrations in this binder. This is a repo of Jupyter notebooks we have demonstrating various things. You can encrypt this data, and then you can do all these different things with it, like join it together. We compute a string metric on these different names. So I like to joke, I've never heard of a business that has clean address data. No one ever contradicts me on this. Addresses at the very least, there's like str period, str versus street, all these kinds of things. And so you need to do some kind of wrangling and cleaning to figure out when two addresses are the same. In this example, we compute how close all these addresses are to each other. We do some basic data science on it. You can do things like search for a thing in a list. So if I had a list of 100 names and I wanted to search for Sheila in my list of 100 names, really the thing that gets returned to me is that, hey, that name appears in row 67. I don't actually need to see what's in row 67 to do that. And this kind of, you can go a step farther and like, I could send you an encrypted name to search for in a list. You don't know that the name is Sheila. You just know that whatever name I sent you occurs in row 67 of your list. So this is live right now, with the exception that I've never found anyone who could keep Jupyter notebooks from crashing periodically. But if you want to go and play with it, it's there. And there's more information on our GitHub as well. You can also check out those other things. Maybe OpenMind is a great place to start if you're just generally shopping. Okay, so we are about at the end. I wanted to make some space for general questions and conversation. If anybody would like to get in touch with me for whatever reason, I'm very active on LinkedIn, and just email me directly. Don't bother writing this down. You can just grab the whole deck if you want off GitHub. I put it, as I mentioned, both in the chat, and it's in the chat on the meetup page. All that stuff being said, that's all she wrote. Questions or thoughts? I'd love to hear what you think. What's on your mind? Did it make sense? Yes, you're right. You are drinking from the fire hose. Maybe that's my. I tried to make the fire hose as, amenable to you as I can. It's a very counterintuitive technology. I don't think anybody really is super comfortable with it the first time they see it, especially. In addition to maybe I just showed you too much stuff as well. And if I did, that's on me.
How much of this stuff is handled by other data packages, Snowflake, and other sorts of software that's data analytical driven?
So this is a very new tech. Most of what I know about is made by companies that do only this. And then some larger companies have kind of like research labs that I don't know what they're doing. It's certainly not. So OpenMind is some kind of nebulous. They might actually be a company. This was made by a giant bank in China. This is a startup. This pretends not to be affiliated with a startup, but it's actually affiliated with a startup named Duality. And so I guess with the exception of Fate here, it's a company that's totally focused on doing that thing. There is some similar stuff implemented various places. And for example, go ahead.
Companies in general are not going to be packaging their data engineering tools with an encryption sort of package. They're going to let the consumer or the business choose their own.
Well, honestly, this is a new technology, and I expect in a few years you will start seeing it incorporated into things like Snowflake. And what I may be actually going to do with the rest of my week is not hunt down Snowflake in particular, but I'm going to be chasing those companies around and trying to convince them to do it. But it's all pretty new. There's different kind of reasons you would want to do it. Like I talk to people at Snowflake periodically, like not a lot of you are hearing about this for the first time. A lot of people at Snowflake have not heard of it before. Let me think. I kind of think if there's any like really high profile places where this is in place now already. Oh, so here's the problem, by the way. My library, for example, it does some pretty sophisticated stuff under the hood to do its magic trick. We try really hard so that if you have something that looks like normal Python code, you can do it with these new data objects and it'll work and it'll do the right thing. But that's not unlimited. So Snowflake has been around a while. It's a lot of work for Snowflake to take all their existing data engineering stuff and integrate this into it. And I expect that is going to happen. Maybe not for Snowflake. I don't know who's going to do it first in the coming years, but it's not there yet, in part because A, it's a new tech, and B, you have to do the work of integrating it correctly. And by the same token, I expect, there's a company called Inveil, and then a few other people in this space. And I'm pretty sure what they did was they went to VCs and they said, well, this new homomorphic encryption thing is our way we're going to disrupt cloud computing. We're going to put this new ingredient in and people are going to love it. And that's going to allow us to get market share from the big boys, Amazon, Google, Microsoft. I don't know that company super well personally, so I don't know how well that's going, but that's kind of where this technology is right now. People are trying to cook it directly into stuff so you don't have to think about it. There's some market penetration. Big companies haven't had the time to respond to that. They might decide they don't want to respond to it. It's all wide open. It's very exciting. But no, Snowflake, I don't think has anything like this integrated. It's probably too long of an answer, but hopefully there's something useful in there.
So, Alex, since this is so new, people that it's actually real.
I could only hear, could you maybe get a little closer to the mic or use the chat? I couldn't quite hear you.
So Dan asked, since this is so new, how do you convince people that it is totally real? Or that it is real?
Like if you walked into a hospital and said, yeah, this is a cool technology, just dump it on your stuff and it'll all be safe. Like obviously the lawyers aren't going to say, well, yeah, that's a cool idea.
Yeah, that's a great question. I'm really an entrepreneur is how I describe myself a lot of the time. I wrestle with this all day, and there's a lot of interesting things to be said about that. Some of them are unfortunately, I think, kind of stupid and weird. So, I had that binder thing on this for this presentation precisely to maybe put my finger on the scale a little bit more, convincing you guys it was real. You can point to things like the guy who made a big breakthrough about this, won the MacArthur Genius Grant. And you can read all these articles about how genius he is and that people should start doing this in healthcare. There was a company called Data Fleets that got some hospitals to do this in a consortium, and then LiveRamp bought them for $48 million, which was a lot of money they made doing that. I kind of hate that the world works that way, but that last one gets you as much traction as like all the math papers in the world. Also, I try to look for people that are in trouble in a way. There's existing technologies for handling some of these problems. There's no denying that. And you have to be realistic and honest with people that, well, if some of that older technology is working for you, like, don't worry about this new thing. It's reasonable to be a little bit risk averse. On the other hand, and I think ad tech, in my experience and the experience of others, is maybe where this is getting the most traction right now. And it's partly because ad tech has these big pipelines with lots of people's personal data flying around. They're suddenly very regulated, and they're willing to hear out the kind of details of why it's real because they really need something new. And this is a new thing that solves a problem for them. To sum up, I've heard a zillion times, the healthcare, this kind of tech in a way is perfect for healthcare, but then healthcare is often very conservative about information technology. And probably it feels like 100 times somebody has told me, yeah, this sounds like a great idea, and we're going to do it when everyone else is doing it, which I think, unfortunately, is very rational, but it's kind of a bummer for me as somebody who's excited about the technology and has committed themselves to evangelizing for it. So that's a great question. It's hard. Been fighting hard on that front for 4 years now.
Looks like you have another one from Naresh in the chat.
Any max duration does EU allow encrypted data to be lived in USA? I mean, 0, basically. It can't go there officially. In practice, it does, and it's semi-illegal, but there's no kind. And one thing I should say, I'm not a privacy lawyer. I learn about this stuff because maybe you've seen it's relevant. I'm interested in the technology. I'm not a privacy lawyer, so take what I say with a grain of salt. There's no kind of story like, oh, you can have it in the US if it's just for a minute. The max duration, I think, is basically 0, honestly.
Yeah.
Other
Okay.
questions?
Yeah, any final questions from anybody?
All right, cool. I appreciate that you guys engaged with me. You've been a great audience. Once again, I'm really sorry I couldn't make it last month. Please feel free to go raid my GitHub and get the slides if you would like. They're there for you. I would love it if you found this deck useful and you did something with it.
Yeah, thank you very much. Really appreciate it.
All right, great. Everybody have a good night.
You too. Thanks.
Thanks, Alex.